I'm Taylor, and I've just been taking a look at the new Altera Agilex 7M FPGA and SoC. So we've taken a look previously at the 5E series and the 7F series, but now we're going to take a look at the 7M series, and this has really been developed to give us support for LPDDR5, DDR5 and DDR4 external memories. But really interestingly, as you'll see in one of the blogs that we're going to post, it also has on there high bandwidth memory in the form of HBM 2E. Now this comes in either 16 gigabyte or 32 gigabyte depending upon the device, but if you're not familiar with high bandwidth memory, what it is it's basically SDRAM dies that are layered within the package on top of a HBM controller. So it's all integrated within the same FPGA package. Now high bandwidth memory, we typically use really wide buses to get that bandwidth and support that bandwidth, and we'll talk about that in a little while. Obviously, when we're thinking about how we get data on and off the high bandwidth memory, it could be a challenge. So to achieve this, the Agilex 7M uses a network on chip that is connected to the user logic. The network on chip is the only way to access this high bandwidth memory. It runs, in the example that we've been looking at, it runs at 1400 megahertz, and as you would expect, it has a AXI4 connection back into the user logic. So to the user to see it, it just looks like an AXI4 transaction, either read or write. Now the HBM controller has actually 8 channels, each of 128-bit wide. However, not every application needs that 128-bit wide, so it becomes a little inefficient. So actually what we can do is we can use 16 64-bit channels instead, which means that we get a better throughput and better performance because we're not having wasteful bits in the 128-bit access that we don't want to use. Now the example we've looked at, the example design, as you'll see in the blog, it is intended to run at about 22.4 gigabits per second bandwidth between the high bandwidth memory, and the example design puts in a varying range of test patterns that change the burst width. We don't need to do any recompilation of that. This is all done in software as we rerun it and connected to quarters as it runs through. As you'll see, if you take a look at the blog that's linked, we'll see that as the traffic pattern, the larger the burst, the larger the transfer, obviously the more efficient it is than doing smaller bursts. So it's a really interesting device to take a look at. And if you're thinking about using a FPGA which needs that high bandwidth memory, then the Altera Agilex 7M should definitely be one of the things that you would consider when you're looking for the device.